Hi, I'm Paul Keoghan from GK Tuition, and in this video I want to talk to you about differentiation. Now the question that I've chosen to go through here is 2018 paper 1 question 8. In this question we're given the symmetric function f of x is 1 over root 2 pi e to the minus a half x squared. Now it's a fairly intimidating function, but nonetheless the first part of the question is very straightforward. It asks me to find the point A, the point where the curve crosses the y-axis. Straight away you should recognize that the point where a function crosses a y-axis, that means that x is equal to 0. So in order to find the coordinates, I already know the x value is 0, all I need to do is find the y value. So if you sub in, instead of an x you sub in a 0, f of 0 just works out as everything stays the same except instead of an x you get a 0. Now clearly in the power here, 0 multiplied by anything, I just end up with 0. And one of your rules of powers is that any number to the power of 0 is equal to 1. Which means e to the power of 0 is just 1, so I can treat it as if it's just gone. And in fact, if x is equal to 0, that means that y is equal to 1 over root 2 pi. So my final answer there is that the coordinates of A are 0 and 1 over root 2 pi. In the second part of this question, we're told that the coordinates of B are minus 1 and 1 over root 2 pi e. We're asked to use this information to find the area of this shaded rectangle. So the first thing you should realize is, right, I'm just looking for the area of a rectangle, means I need to find the length and I need to multiply it by the width. So that's the first thing you should write down. If this is the coordinate minus 1, 1 over root 2 pi e, you should recognize that directly below here must be the coordinate minus 1, 0. And that directly across from here must be the coordinate 0, 1 over root 2 pi e. Okay? If I know that that's the coordinate minus 1, 0, then clearly the distance from the origin to that point is just 1. So I know that that distance there must be 1. And if that's the coordinate 0 over 1, 0, 1 over root 2 pi e, clearly the distance from the origin to that point, that distance must be 1 over root 2 pi e. Okay, so already I have one of my dimensions. You can call that your length or your width. Now, it told me that in the question the graph is symmetric. Because the graph is symmetrical, I know that if the distance from there to there is 1, the distance from here to here must also be 1. So C must be the coordinate 1, 1 over root 2 pi e. So I know that that distance is just 1, which means that now I know that my width is 2 and my length is 1 over root 2 pi e, which means that the area of this rectangle is 0.484 units squared. And I can just leave that as my final answer. In part C, we're asked to use calculus to prove that f of x is decreasing at C. Now, if a curve is decreasing, that just means that the slope is less than 0. The easiest way for us to get the slope of this function is to get the first derivative. So this question basically just means show that the first derivative is less than 0 at the point 1 over root 2 pi e. So what we need to do is get the derivative of this. Now it looks intimidating, but it's actually very straightforward to get the derivative of something like this. If I'm getting the first derivative of this function, first of all you should realize that 1 over root 2 pi is a constant. That's just a number, so you don't need to worry about it. You can just rewrite it. Now, I've done out a few examples here to help explain this one. According to the log tables, to get the derivative of e to the power of something, it just stays the exact same, but then I multiply by the derivative of the power. So for example, if I asked you to get the derivative of e to the 5x, it just stays the exact same, e to the 5x, multiplied by the derivative of the power. The derivative of 5x is 5. So that's all. I'm going to do the exact same thing with e to the minus a half x squared. First of all, I'll just rewrite it. It stays the exact same. E to the minus a half x squared, and then I have to multiply by the derivative of the power. The derivative of minus a half x squared. Now I've done this one out over here. If you have y equals minus a half x squared, to get the derivative of that, you would just bring the power in front. It would become 2 times minus a half. 2 times minus a half is just minus 1. And the power decreases by 1 and just becomes a 1. So I need to multiply by the derivative of the power, so I need to multiply by 1x. So the first derivative there is just the number stays the same. I rewrite e to the power stays the exact same, and then I multiply by the derivative of the power. That's your first derivative, and now I need to prove that this is negative at these coordinates. So in order to do that, I just need to sub in the x value. So at C, I know that x is equal to 1. So what I'm going to do is just rewrite my first derivative, except this time I'm going to sub in a 1. And if you sub in 1 in this case, you can then just plug it all into your calculator. That'll just be 1 times 1. And if you plug all that into your calculator, it works out as minus 0.24197. So therefore, you could say so you could conclude by just saying that f dash x is less than 0 at C. In other words, the slope is negative at C, therefore it's decreasing. In the final part of this question, we're asked to prove that the function f of x has a point of inflection at B. You should recognize that at a point of inflection, the second derivative is equal to 0. So you need to get the second derivative and prove that at the coordinates of B, the second derivative is equal to 0. In order to get the second derivative, you need to differentiate the first derivative. We worked out the first derivative in part C. It's 1 over root 2 pi e to the minus a half x squared times minus 1x. You should recognize that this is an exponential multiplied by algebra, which means that this is your product rule. In this case, the first section here can be your u. I've used u as 1 over root 2 pi e to the minus a half x squared. And in order to get du dx, I need to differentiate that. But I want you to notice something here, that u in this case is actually just what we differentiated in part C. This is the original function. So we've already actually differentiated that. It's the exact same as part C. The derivative of u becomes 1 over root 2 pi e to the minus a half x squared multiplied by the derivative of the power, which is minus 1x. Then my v is just minus 1x, which means that dv dx I just differentiate and I get minus 1. Now, according to the log tables, when you're using your product rule, the derivative is equal to u by dv dx plus v by du dx. So that's all I've done here. To get the second derivative, then, the derivative of this, if I'm using the product rule, it's u, which I've plugged in here, times dv dx, which is minus 1, plus v, which is minus 1x, times du dx, which is all of this. And I've just simplified this down a little bit. On the next line, the minus 1 I multiplied by the 1 on top here, so that just becomes minus 1 over root 2 pi e to the minus a half x squared. To simplify the second term here, I just multiplied the minus 1x by the minus 1x. Minus by minus gives me plus, x by x becomes x squared. And it's x squared times 1 over root 2 pi e to the minus a half x squared. And now we can actually factorize this because we have common terms here. So I want you to try this yourself. See if you can factorize by factorizing out what's common. And I'm going to do it up on the top of the board here. Okay, so previously we've simplified our second derivative as much as possible on this line. And remember, the whole point of this question is to prove that there's a point of inflection at the coordinates of B. The coordinates of B are minus 1, 1 over root 2 pi e. And to find a point of inflection, you let your second derivative equal to 0. So in this case, I just get my second derivative and I let it equal to 0. And on this line, you should recognize that you have a common term, that 1 over root 2 pi e to the minus a half x squared is in the first term, and it's also in the second term. Which means I can just factorize out 1 over root 2 pi e to the minus a half x squared. If I divide the common factor into the first term, I'm just left with minus 1. If I divide the common factor into the second term, I'm just left with x squared. So in fact, on this line, at least now I have something that looks a bit more familiar. And remember, if that is equal to 0, we can now solve it. First of all, you could let this bit equal to 0, find the value of x, but clearly the one I'm concerned with is this one. I can let minus 1 plus x squared equal to 0. And if you just rewrite that, it's x squared minus 1 equals 0. And if I solve this out, it's the difference of two squares, so your two answers there for that one work out as x equals 1 and x equals minus 1. So I let my second derivative equal to 0, and when I solved it, two of my answers are x equals 1 and x equals minus 1. That means that a point of inflection exists when x equals minus 1 and when x is equal to 1. And they asked me to prove that at the coordinates of B, where x is minus 1, that a point of inflection exists, and I'm after doing that. So my final answer there, once I've solved and I get x equals minus 1, I'm on full marks. So I hope this video made sense. If there's anything there you're unsure of, then just make sure you let me know in class or send me an email and I'll try and clarify for you.